All right, welcome to our lesson on traversing arrays. I want to try and conduct this as though I were in the classroom to kind of give you that full benefit. So I'll be walking through every slide, emphasizing what's important, what should end up in your notes, key ideas to retain going forward. So like we do most lessons, let's go ahead and begin with our warm-up. Um, what does this code do? Make a prediction and try and put that prediction in your notes. And then go ahead and plug this into Eclipse. Let's get in the habit of writing that array syntax. I think that's important. And execute the program and see what happens. See if you were right. I want to point something out. We didn't get to emphasize this in our introductory lesson for arrays. There is a shortcut for creating a new array object. The fancy word for that in computer science is instantiation. So the fancy way to instantiate an array is what we see here on this line. And what we're doing is we're making a new array. It's an array of ints. I'm calling this array, its identifier is stuff. And then I wanted to just fill that array up right away from the get-go. So what you see here is that there are 1, 2, 3, 4, 5 elements in the array, so it's going to have a length of 5. And there are numbers already put inside of this array. So the number at index 0 is 2. The number at index 1 is 3. The number at index 2 is 5. Index 3 is 7. Index 4 is 11. And we know that there's nothing at index 5 because arrays are 0 indexed, and this has a length of 5. This is just a shorthand way of combining creating the array and populating the array rather than having to do, normally it would be 6 different statements, right? You would create the array and then there'd be one statement for assigning each of the elements of that array. I'm going to give you an opportunity to pause here, make your prediction, read the code, see what you think, and then type it into Eclipse. And once you've checked to see if you were right, go ahead and hit play and come on back to the video. All right, so I think what we should have noticed is that this program used a loop that went from 0 up until the length of stuff. And as some of you probably surmised, this stuff.length is the way to get how long stuff is. In the case of this particular program, stuff is going to have a length of 5. Now, I know some of you are probably thinking, well, where are the parentheses that come after length? And the answer to that question is length is a property of the array, which means we don't necessarily need a method to access length. It's kind of like a variable that belongs to array. So when we want to get an array's length, rather than having to say length parentheses or size parentheses, we can just say dot length, and it'll know to get the same thing for us. All right, so we go from an index of 0 up until length, but very important that we're not including length. And we get this number flarg. It's one of my favorite made-up computer science words, flarg. And we add stuff of index. Stuff of index. Well, what does that mean? When we start a for loop, index is 0. So the first time, and flarg starts as 0. Again, a variable table could be helpful here. When we get into the body of the for loop, we're going to say flarg plus equals stuff of 0. So what term is in stuff of 0? If I go to index of 0 of stuff, I will see that a 2 is in there. So I'm going to add 2 to flarg, which was currently 0, so flarg now has a value of 2. Then, following my for loop diligently, I update the index. Index is now 1. 1 is less than stuff.length, which is 5. That's true. 1 is less than 5. We come down here. We see now we're looking for stuff of 1. What is the element in the array stuff at index 1? And that is this 3. So we add 3 to flarg. Flarg's previous value was 2. We add 3 to it. Now we have flarg has a value of 5. Update our index. Index is now 2. 2 is less than 5. What is the element at index 2? It's 5. 5 plus 5 is 10. The value of flarg is now 10. And we can see as we go through this that all flarg is, it would be more appropriately named sum or total. And it is just totaling up all the values in the array. I want to highlight, this is something that should be in your notes, that we chose in our for loop to go up until length but did not include it. And what that means is by the time index becomes 5, we would return false when we said 5 is less than stuff.length. So we will not run the risk of indexing out of bounds of our array because we used the correct logical operator. That's pretty important. So you'll want to make sure when you make a for loop to visit every cell of an array that you're going to use this kind of logical operator. It's usually just a better way to go. So we print out this total, and then this whole double flarg divided by stuff.length. Well, a total divided by the number of elements, that's simply just going to be the average. A question I would ask you to consider is, why did I use an explicit cast of a double here? And if you think about it for a minute, the type of flarg is int, and stuff.length, this may not be obvious, but if you thought about it, we would think stuff.length is an int. And if I just did flarg divided by stuff.length, we'll end up with that weird integer division that Java can do that gives us an imperfect number. And what we're looking for is probably something that is decimal precise. So we would convert explicitly whatever flarg is, which 2 plus 3 is 5, plus 5 is 10, plus 7 is 17, plus 11 is 28. We would convert flarg from the int 28 to the double 28.0, divide that by 5, and we'd end up with a decimal. I think that's like 5.6, I want to say. So there it is. That's your warm-up. So we're starting, this lesson should correspond with section 7.2 of your textbook. I would ask that you read that tonight to help reinforce what we're going to talk about in this video. And the idea is we're going to discuss traversing an array. And traverse is a fancy word that simply means to go across. And what we did in our warm-up is actually an example of traversing an array. We visited every element on our array from element 0 to element 4, which is the last element in the array. And we did something with that. There's a lot of ways to traverse an array, and we're going to find that looping, like using a for loop, is a very good way to do that. So that's the idea behind traversing an array. All right, here are our objectives. I will pause for a moment for you to read and take this in. Okay. All right, so we are going to give you a chance to kind of practice some of the array stuff that we worked with yesterday. We learned all the syntax, we saw a few applications of it, but we really didn't get the chance to get our hands on the keyboard and see what creating an array is all about. It's got those angle brackets, it's got that interesting syntax, so it's worth kind of examining. So what I'm going to ask you to do is pause the video, head on over to Eclipse, make a program called Array Practice, and see if you can have it meet these 4 goals below. So in the same main method, you're going to make an array of ints that's a length of 5, and initialize all the elements to a value of 2, 10, 20, 50, 100, and 1,000. And you can use the shortcut that I showed in the warm-up. You could assign each value individually. That's totally fine by me. You should be getting to print out each element of the array separated by spaces. This is going to involve you having to traverse the array probably with a for loop. And that's the first thing you want to do. Well, I guess it's the second thing you want to do after you make the array. The third thing is go ahead and traverse the array and multiply each element by 2. And let me be explicit. What I mean is if the value is 100, I want you to replace that value in the array with the value 200. So go through and double each element in the array, and then print out each element in the array separated by spaces and see what happens. The act of printing out an array is something that we could write a for loop to do. It is itself a type of array transversal, visiting every element, printing it out. But in the interest of abstraction and taking advantage of the tools that we have in front of us, I'm totally going to allow you to use this method arrays.toString. And what that does is if you pass your array into the parentheses at toString, it will convert your array into a string, hence the name toString, that makes it a lot easier to print. So your syntax should be something like system.out.println arrays.toString of, and then feed in the name of your array, whether it's numbers or names or stuff or whatever you've named your array. Okay. Let's see here. You know what? You can disregard this. Don't. It's okay to use it. All right, here's what, oh wait, I guess you should probably take a moment to try and do this on your own. You've probably already seen the solution, but here's the solution for making this work. So here I've done the longer way of filling in all the integer values. And the first thing that prints out every element of the array, that's this for loop right here. And again, we see we start at 0, we go up until length, but we don't include length. And we access my array of I by referencing the index of the for loop. Every time we loop, I'm going to access a new element of the array. So this goes through and this prints everything out. Then we go through and we say, hey, you know what? My array of I. So we're looping through, we're transversing through the array. And we say, you now times equals whatever you were, you are now double that. And this is a syntax that's totally valid for using with arrays. Then we're going to say, for the last time we go through and we print it out again, right? That was the idea. So that was one solution for this previous slide. So we went through this very, very quickly in the introduction lesson, but I want to emphasize that when you pass an array as a parameter to a method, the method can change the contents of that array without needing to return the modified array. And I know that might sound like gobbledygook, but let me try and make sense of what that means. Normally, if I take an int and I pass that int as a parameter to a method, and the method monkeys with that int, it increases it, decreases it, and does a whole bunch of fun stuff with it. We know, based on how passing primitive data types works, that is something that's called pass by value. What that means is, rather than actually passing the variable, we are passing a copy of the variable. So if I pass the variable x, which is an int that has a value of 2, to some other method, and I mess with that value that was passed in that method, well, even after the method call, the value will stay unchanged. The variable x, which is an int, will still be 2 because we didn't actually pass x, we passed a copy of x. That's how primitive data types work. This is not true with arrays, and it's generally not true with objects because arrays and objects function by something called pass by reference, which means that when you pass the object, when you pass the array as a parameter to another method to use and mess with, because arrays and objects are so complex, they're much more complex than primitive data types. When you mess with it in the new method, it is going to keep messing with it everywhere else in your code. So we would say that the changes for arrays are persistent across methods. And that's just something to keep in mind. I know that's an abstract idea to think about, but it's a common reason for bugs in programs later. And we're actually going to have a whole other lesson on the difference between pass by value and pass by reference. But the short answer is one means to make a copy and allow to manipulate that copy independent of the original variable. Pass by reference means that whenever you change it, it'll still refer back to the original object. So that's just something to consider. More on this later. Okay. I'm going to leave this screen up. I'm going to do a little pause. See if you can figure out what's going on with these methods array thing and double each element. Array thing and double each element. Go ahead. Okay, so array thing, what does it do? So it makes this new array of ints. The type is array of int. The identifier, the name of it is 4nums. Makes sense because we put 4 numbers in it, 1, 2, 3, and 4. And then we call this method double each element. Thankfully, we named this fairly explanatorily. I don't know if that's a word. I guess it is now. We gave it an explanatory name. And what does double each element do? Well, it takes an array of ints as a parameter, and then it visits, using a for loop, each of those items, and there it is, doubles each item, and then it prints out that new doubled value, right? So then we say system.out.println to make it on a new line. But the idea is we visit each element and we print it out doubled. I think if I had to redo this slide, I would concatenate a space in there so we could see between the items, but you get the idea. Then the question is, now that double each element has been called and it has finished executing, when I come back up here to array thing and I look at this for loop, 4nums.length, for visiting each item, again, we traverse the array. And here we are printing out each item for this for loop. So the question we want to ask ourselves is, what prints out right here? Is it 1, 2, 3, 4? Or is it 2, 4, 6, 8? And the answer, and it might be unintuitive, it's why we're talking about it, is that it's going to be 2, 4, 6, 8. The idea behind arrays is that if I pass the array to another method, and that method changes the value of the array, when I come back, that change is persistent. Now, I know you might be thinking, I don't believe you, this seems crazy, this is different than how passing primitive data types has worked before. Pause the video right here, put these two methods into a program and execute it and see what happens. So there you go. So here is examples of different ways that a method could take a parameter and mess with it. And we want to talk about whether that change persists outside the method or whether we were just manipulating a copy. So here we have 2 different programs. These methods are a part of one program, and these methods are a part of one program. And the idea is that we make a variable. This time it's a single int I, and we double it, and we pass I, which is the value 5, down here to the double it method, and we double it. We say take that parameter and double it, print it out, and then come back here and print out the original variable I. Very confusingly, this is going to print out 10, 5. When double it is called, we print out the double 10. But system.out.println, this is actually going to print out 5. The value of 5 is unchanged. This was passed by value. We sent a copy of 5 to the doublet method, which was messed with, but the original value I stays the same. This is going to be different than if you did string s as word and passed it to doublet and concatenate it. And I would encourage you to try these 2 different scenarios and see what happens. Here's a spoiler alert. Strings, as we've been saying all year, are a little bit weird. They can be the exception to the rule, but it's worth trying these both out in Eclipse and see what happens. So I'll leave that up to you. All right, so values that cannot be changed by another method are primitive data types, and if you did the experiment from the last slide, strings. The reason for this is complex. We're going to really be spending the next 4 months to get this right, but what you want to do is primitive data types are passed by value. That's why their original value isn't changed. And strings, whenever you modify a string, what it's actually doing is it's creating a brand new string and erasing the old one, which is why it doesn't quite act like other classes. Arrays and objects are passed by value and can be changed by another method. You don't have to return that value for that value to be persistent. . All right, so let's examine. I promised yesterday that we were going to reach the fourth and final kind of loop in class. And here it is. So we first learned the for loop, which is a definite loop. Then we learned a while loop, which is an indefinite loop. Then we learned the do while loop, which is an indefinite loop that guarantees the loop will be executed one time. Here is the for each loop. And I've written the for each loop right here. It's got this bizarre foreign syntax that I know must seem strange. And I've written its equivalent over here so that you can kind of see using for loop technology how this would appear and how the for each loop makes it simpler. The notion behind for each is actually really quite simple. For each item in a collection, in this case an array, for each item in your array, perform some function. And so for each is one of the best ways to traverse an array. So here's what it might look like. We might have a method called printArray that takes an array as a parameter, and then I'm using this for each loop. I'm saying, hey, for int x of array. What does that mean? It means go to the collection array and pull each item out. And I'm going to specify that each item type is an int. And every time you run this for loop, give me a different int out of this array, starting with the first element, ending with the last one. And when you pull each item out, and it's not to say that you're removing it from the array, you're just accessing it. When you pull each item out, I'm going to refer to it by the identifier x. So what that means is when I say system.println x, this will just print the whole entire array. It's going to say, hey, this is an array. It's an array of ints. Visit each int in this array, and every time through the loop, refer to the new int being accessed as x. Compare that over here to the for loop that we already know. Look at all the shorthand that gets chopped out. We're not having to specify that we're starting at 0, or that we're ending at length, or that we need to increment by 1. So right away we should see one disadvantage of the for each loop is we lose access to an index. And then we don't have to take the time to use the array syntax to access each item. We can just say, hey, I know everything that comes out of here is going to be an int x. But in the for loop, we have to say, go find me the array at index of I, so starting at 0 and ending with up until length, and put that into x and then print this out. So these are two equivalent ways. You will practice more for each loops later in this unit. So there it is, array traversal. Array, I've been teaching too much geometry. Array traversal, processing each array element sequentially from the first to the last. Or at minimum, it means to visit your data collection. So here is the different ways we might do it. Here is the traversing loop and a for each loop. Both are valuable for traversing, and you will not exclusively use for each to traverse. There's different ways to do that. All right, so I wanted to build some time for working on Practice It. If you go to the website, I've uploaded all the lectures for this unit, including the slides you just looked at. I've uploaded all of the homework. The homework is there just from what you've learned in the introductory lesson and this lesson you've just watched. You should be able to complete at least half the Practice Its, if not more. They correspond to sections 7.1, 7.2, 7.3, and I believe 7.5 in our textbook. If you have any questions, email me. It has been my pleasure, and enjoy the rest of the period. Thanks.